Pablo Yanyachi. The title is Space Geodesy for the monitoring of volcanoes and surrounding fields of Arequipa using the Arequipa Station as a reference.
Good evening, everybody. Thanks for attention. I will talk one idea that we have a lot of time before. The idea was using the space geodesy for monitoring volcanoes and surrounding hills of Arequipa using the Arequipa Station as reference. We have agreement with NASA, University of San Agustin. We funded Astronomical and Aerospace Pedro Paulet Institute at the Universidad Nacional de San Agustin. And we work with help of Claudia Carabajal, Jean-Paul Boy, Kevin Rodríguez, and other members of IAAPP-UNSA. We are in Arequipa. This is the observatory of Arequipa Station, but in this place it's a function, the institute, and we we have another idea to do a center, acquisition and processing of satellite data center that is continue with this idea. What is the area under study? It's Arequipa City. It's in the south of Peru. The volcanoes, Misty and other volcanoes are very near to the city. At present, we have 1,382,730 population. And of course, has some concerns, by example, fumaroles in the crater, grow with cancers. Arequipa is located in volcanic zone of the Andes mountain range. Is in the subduction zone between Nazca and the South American continental plate. We have the last earthquake, 23 June, with magnitude 8.4. We have the station, this place near Arequipa City with this population, but we have in front 3 volcanoes. Near is a Misty, Picchu and Chachani. The most near is 15 kilometers to the top line. What is the main objective? It's analyze and monitor and with space geodesy technique. We can see the observatory. If we can see behind the Misty, Chachani, and Picchu. The 3 volcanoes are very near, but we have 2 in the station LRS system, south 2 from 70 to 19, LRS 3 from 19. Dory system from 19, and GPS after GNS station started 94. And the last was GNS station, CNS 2013. That's that we have at present. That inspiration to do that was the two-color electronic distance meter in operation at Parkfield, California, built in mid-70s. You can see the magenta light is a combination red and blue laser light that expanded to 20 centimeter diameter. Can measure distances to 1 millimeter precision over 10 kilometers long baseline. But we need to know average temperature and pressure along the path, 10-kilometer path, we know better than dot point degree and 1 millibar. However, the two-color electron distance meter measured the travel time of light with two wavelengths, red and blue. Due the atmosphere is dispersive, there is a difference in travel time with a direct function of temperature and pressure. But that's reason we need to know the temperature and pressure along the path. The differential travel is used to measure the average temperature and pressure in the atmosphere, calculating the index of reflection. With the index of reflection, the distance is computed from the travel time of the one of the color. That's inspiration for one side. At the other side, we note the ground deformation associated with shallow magma intrusion. What this means? That the volcano, due to the magmatic intrusion, can suffer deformation in the surface. This can we do a model of deformation. With these two ideas, we try to continue with our project. We have before two tries, two posters in 2014 and 2018. Of course, we try to buy a leader with two colors. Laser, but we have a problem, logistic uses. At the university, we can buy this instrument. But what we do, we do some experiments or measurements in the station. From Teller S3 station, we do measurement to two targets, target A and target B. And mounted GNS antenna over a laser reflector. We additionally put a meteorological station, one mid-tree and another development meteorological station at the university. We do some comparison for the precision in measurements, but with this instrument. Other thing that we do, we validate the results, LRS results, and we process the result with the normal pre-calibration results and process with simplified equation for calculate distance with laser using the time and data. We haven't a station at Misty. We used data from one station or from other institution in Gemet in Arequipa. We processed the data, this station, MTP, to AREC and NTP to AREC because we have two GNSS stations. We can establishment baselines mean standard deviation in east, north, and up. If we can obtain these results that we have no change. We use it for this some other GS station, and we process every 5 days. Almost is 1 year processing data. What is the conclusion for at present for us? We applied GNS technique to determine the formation and the Misty volcano. Of course, no deformation was observed between 2021 or 2022. We get process the data GNS system with Gamit Globca software. We do analysis with MATLAB. Additional, we do topographic and geomorphical studies of monitoring points in the Misty volcano, Chachani volcano, and Pichu Pichu. In total, 5 monitoring points are pretended to be built. Still, we have the idea. We put together a GNSS system with the laser reflector. At the pillar, 1 meter, 8 centimeters. This is the same consideration to put in the volcanoes. The low-cost meteorological station that was developed is not sufficient accuracy, but that reason we can purchase or improve the design. The laser data processing has been carried out using simplified equation, obtaining a standard deviation of 4 millimeters, which is typical of the TLRS system and Gaussian distribution. No? We want to send to NASA Goddard Space Flight Center for letting us to use the TLRS system and the station. That's it.
Thank you very much. I should comment that ILRS is having a workshop in Arequipa next year, so please remember the view. One short question is, the volcano, Misty, Chachani, and Pichu Pichu, active volcanoes or dead volcanoes?
Misty is active.
Oh.
At the present, no evidence that the Chachani or Pichu Pichu is active.
Okay, thank you. Any other questions? Nothing online? Okay. Okay, thank you very much, Raul. Thank you. So this is the end of the session 3.